operation diagrams of an induction motor stator designed by engineer Ismail Yusuf Adubazi. The first step to take is to estimate the dimension of the slots to accommodate the wires using measuring instruments. Take the cross-sectional area of the slots, A1. Measure the diameter of the strand of wire to be used with micrometer screw gauge. The area of the wire is calculated as A2 is equal to pi d squared over 4. Let that be equation 1. V2, the base area times height, which is pi d squared over 4 multiplied by height 2. Equation 2. V1 is equal to base area times height, which is A1 times H1. Let us go to the next slide. The estimated number of wires per slot is given as number of wires per slot is equal to A1 H1 over A2 H2. Let that be equation 3. The group of core. There are two major equations as well that you are going to use for putting the coils. The fourth equation is group of coils is equal to outer span all over 4. Which is that equation 4 here. Outer span is equal to number of slots all over number of faces times pole pairs. The next slide. The results. Assume a group of coils of 2 for a 3-phase machine running at a speed of 1500 rpm. From equation 3 above, 2 will be equal to outer span all over 4. By cross multiplication, we have outer span is equal to 8. Recall that speed is equal to 1/20, that is synchronous speed, is equal to 1/20 all over number of poles, where P is equal to number of poles and F is equal to frequency. Given a speed of 1500 rpm, the number of poles will be equal to 120 times 50 over 1500, which is equal to 4 poles. Hence, pole pairs equal to 2. Using equation 4, 8 will be equal to number of slots all over 3 times 2, where 3 is the number of faces and 2 is the pole pairs. Therefore, number of slots will be equal to 48. That will take us to the next slide. The figure is the first step for the rewinding, which is 48 slots. 1, 2, 3, 4, 5, up to 48 slots. What that is from the calculation above, the first slot, which is 1, will go to the 8th slot, that is outer span. For the fact that the group of coil is 2, the adjacent wire will go, making 1, 2. That's the group of coil. You can see there's no wire that is cut, it's continuous. This is going to be the start and the end. Do the same thing here. The start, it goes round. Now the outer span is still 8. If you count here, this is 1, 2, 3, 4, 5, 6, 7, 8. You do the same thing here. The outer span will be 8 as well. 1, 2, 3, 4, 5, 6, 7, 8 up till 48. That is the first set of the winding. Now, the second set, when you are going to do the second set, for the fact that the group of coil is 2, you will leave the first 2 slots, 1, 2. Then you go to the next, the third one, which is you start the counting as you did previously. 1, 2, 3, 4, 5, 6, 7, 8. As you are going to see the next slot, it's a color. You can see that from here. 1, 2. You start from here. 1, 2, 3, 8. You do the same thing until the end. If you are done with that one, you'll be left with two here, outside here, and two here. Now that's what makes the other one. This is the complete figure. Now, connection scheme. Yeah, for the connection schemes, for the fact that it's a 4 pole, you will have U1, 1, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. This is U1 representing U1, V1, W1, U2, V2. You are going to connect end of U1 to end of U2, end of U1 to end of V2, end of W1 to end of W2. The same thing here, end of W3 to end of W4. At the end, you see that the flow of current is supposed to go the same way. To go in this way, come down, this way, and to come down. The same thing here. Go this way to come down. The third one. When you are done with that, the next slide shows if you want to connect the motor as a star. At the end, you see you will have 6 wires. This U1, V1, W1, U2, V2, V2. You have 6 terminals. If you put U1, V1, W1, you have to be very careful. If U1, V1, W1 is here, at the downside of it, you have to be very careful. If U1 is here, U2 cannot come here. That's going to be short circuit. If V1 is here, V2 is not expected to be here. W1 is here, W2 is not expected to be here. That is why you see that the labeling goes this way. U1 and here it is W2. V1 and here is U4. It's okay. As a 4, the way it is, they are labeled here. We have U1 here, W4, V1 here, U4, V1 here, sorry, W1 here, V4. That is it. The star connection is this way. If you look at, we mentioned that it's a 4 pole. This is the idea. If you read them 1, 2, 3, 1, 2, 3, 1, 2, 3, you can see that this section is a pole, this is a pole, this is a pole, this is another, the 4th pole. That's the orientation. Now, this is just a graphic to show which one is a south pole, which one is a north pole. It's supposed to alternate to aid each other. You see that the current, you look at the S here, this arrow is pointing upward, that is south pole. If you look at the north pole, the arrow here is pointing downwards, that is north pole. That this is star connection. Let us see the next slide for the delta connection. Oh my god. If it is delta, I'm sorry, the delta, you will have U1, this to down, this, and this is joined to this. That is delta connection. Now, for a single phase electric motor, you have group of coil. You use the same formula, and this is the calculation. The number of slots, and that number of phases, you put it live and neutral, you put 2 here, while the pole pairs, you put 2 here, because the speed is still 1500 rpm. Now, this is the winding scheme for the 32 slots. Remember, we want to connect this one as a single phase. This is the arrangement for the one. On this note, you have two windings on the stator. We have what is referred to as the auxiliary winding or starting winding, and the running winding or main winding. The green colored is the main winding is tagged as the main winding, while the outer one, the red one, is tagged the auxiliary or starting winding, as seen here. Now, when you want to, what we need is just, you can see from the previous slide, we have four terminals, which is one, two, three, four. You need just two terminals. Next slide, you will join these together. The auxiliary winding is connected in series with the starting winding, and so the starting winding is to give, the starting capacitor is to give the electric motor at least 75% of the starting torque. Then you have live neutral. Subscribe to my channel for more information. Thanks for listening.